Three metrics to improve your game. This is going to be, as I was saying, a weird talk. The first thing that we have to address is the elephant in the room, math, right? But we're going to get to that in a bit. My name is Isaque Sanches. I'm a senior game designer at Ubisoft Redlynx. Before that, I worked in VR, cognitive science, mobile, free-to-play, in DPC. I would say that I'm a generalist game designer. This is going to be a very abstract talk. If you like my presentation, follow me on Twitter. I'm going to have that screen at the end again. Or if you have any questions about the talk. As I was saying, let's address the elephant in the room, math. But I hate math, right? A lot of people have been giving me this feedback. I've been workshopping this idea for quite a while. And there's some mixed results, but usually like the math part is like the thing that turns people off. So as I was trying to say before, this is not really a math talk, or I've kind of taken the math out of the math talk. It's more a design talk. And before, like for the people who are not convinced that this is not going to be like trigonometry and stuff like that, I would like to disprove this sentence, because you actually, it's sort of a cliche at this point, you like math. Math is kind of everywhere. Like it's so cliche to say like math is in nature, is in like architecture, you see math. Math is in everywhere. Yeah, and actually if you like games, games have a lot of math, right? So if you like games, you like math, right? And yeah, I'm not going to make that argument, but just to say that the math that we're going to focus here on is the more intuitive sort of math, like this. No, actually, not like this, right? This is the type of math that we're going to focus on, type of math that if you fail, it's very exciting, you take a bowling ball in your face. Well, before we get to the math part, we actually have to introduce a few concepts. This is where the design part comes in. A lot of fancy sounding names, readability, resonance, etc., etc. We're going to go into that. After that, we're going to go into a couple of awful sounding, even more awful sounding words, and then the actual math part at the end. Right, another thing. So as I was saying, this is very abstract. The feedback that I got was that it was kind of boring. So you're going to notice a lot of beautiful pictures that have nothing to do with one another, completely unrelated, just to kind of distract you and like to make you feel that you're actually looking at tangible stuff. So again, this is not about a forest, but nice change of pace, right? What is information processing? So information processing is a cognitive skill that is part of, or a cognitive ability that is part of a larger family of cognitive skills. Like neuroscientists study this type of stuff. It's among stuff like attention, memory, reasoning, deduction. And the definition for it, or a definition that I found online, is the cognitive ability to interpret incoming sensory information. What does that mean? Basically, in like plain English, your ability to read the world, to parse the world. And that usually is measured in accuracy and speed. Put a pin on that. So if we were to test information processing on two individuals, imagine, we have individual 1, individual 2, and both are looking at a teapot, right? Maybe one takes 9 milliseconds to identify it as a teapot, and the other one takes 7 milliseconds. That's the difference in information processing. That's basically how you will see, okay, the two people have different abilities on that, like you measure with time. It's an interesting thing, but in design it's not really useful. Actually, in design, we usually want to bundle people together to have sort of an average, right? So instead of focusing on individual A and individual B, you do an average, and then you try to shift the focus to the object, not the subject, right? So in general, you could say that those two people, which are, let's admit, a very limited sample, but you could generalize this, in general, one teapot reads really faster than the other one. And that's actually what we do intuitively in design, in game design, right? I've heard a lot of game designers use this word. It's not a formal word. I never saw it on a formal design book, whatever, academia. But like usually when I talk to designers, they talk about readability. And I mean, I think that's what they mean. Readability is the ease at which you parse an object or a concept or a construct. And that could also be measured in time. So let's take a very simple example. This is not a concrete game. Whenever I'm specifically talking about concrete games, I'm going to have like the name of the games. It's an imaginary game. I guess some of you have played point and clicks in the past. And point and clicks, some of them are great. And some of them suffer from a lot of problems. One very famous problem in point and clicks is moon logic, right? And imagine then you are in this scenario and there's a secret door. How do you solve this? Well, you had to combine the plant with a typewriter. You're like, what? That doesn't make any sense. It made sense in the designer's mind. It doesn't really make sense, right? And let's distinguish this from another problem, which is also, funnily enough, very common in point and clicks. Actually, it wasn't really the typewriter thing. You needed duct tape. This is the duct tape, those 4 pixels. So pixel hunting is actually also a very, very huge problem in point and clicks. But those 2 problems are very different from one another. Wouldn't you agree? Like in the first problem, it's really about prior knowledge. The user doesn't understand what's going on because the player, will have to look at a guide and understand what's going on without like any sort of explanations, without seeing the solution in a guide, in a tutorial, in a let's play. There's really no way of solving it. While the other one is about legibility. The 4 pixels could read as duct tape, could read as anything else. And those 2 things are very different. Actually, let's look at 2 other examples, just for redundancy. Let's suppose that my sample of players is colorblind, and I tell them, you should look for the tree that's the most green. And they see it like this. It's not really about prior knowledge, right? It's about legibility. Well, if I had tried to solve that cipher, and they didn't really know the rules, or didn't have the actual cipher, they wouldn't know. It's not really that it doesn't read in a way, but it doesn't read in another. So let's distinguish those 2 cases. Readability actually is 2 different things. Legibility and resonance. Legibility is about the universally obvious, while resonance is about similarity to other things, piggybacking, having that prior knowledge. Those 2 different concepts are very abstract, and if you go on Wikipedia or in a dictionary, they're kind of interchangeable. I'm using some liberty to define them, and the math that we're going to focus on, which is again very light, is actually about those 2 concepts. So for sake of trying to make those very clear, I'm going to use more examples. Let's do a graph thing, right? And let's take an example of something that is highly legible, but very, very not resonant. Tetris is very famous now, but when it was launched, actually nothing looked like it, right? And immediately, without any tutorial, without, like, no one read manuals at the time, right? People intuitively knew how to play it. Why? Because even though it doesn't look like anything, and even though there's really not a lot of resonance before it, now obviously if you make a Tetris game, everyone knows what Tetris is, a child could play it, right? Because children at like 1 year old know how to make collisions. They play like with children's toys, like obstruction and collision. That's very like cognitive science 101, right? Like you kind of learn that intuitively as you grow up. And so like obviously like even maybe you could make a non-human play this, like an ape or something. Whereas this would be in a very legible and not resonant. We're going to look at another example as well. And then we're going to focus on the opposite scenarios. But let's, for just the sake of being for clarity, let's focus on another example. And maybe a more contemporary one. Plug and Play is a game. I don't know if anyone played it, but is a game that you actually don't need to be very gamerish to understand. You can put any child like to play the game, or like any, like you can take anyone really, be it someone that's been very versed in the language of games or not, and like here even the task is very obvious, right? Like you can kind of understand that one needs to fit the other, and yeah, there's nothing as well like it when you compare it to other games in the market. So those two games would be here in the graph. As I said, let's look at the opposite example. Anyone that wants to join a tabletop group will have a nice time, but anyone that wants to kind of understand what's going on alone will have a very, very, very bad time, because at this point, for instance, Dungeons & Dragons, it's just a pile of documentation with a lot of hidden rules and a lot of stuff that is sort of implicit. It's actually a thing that you are onboarded with your friends, and that's really a nice example of something that by itself is kind of illegible, like throwing X dice to, like, it doesn't really read in a legibility scale, but for resonance, it's actually all built around that. Another example of that, going to video games, is this. Like Paradox Games, for instance, and there's other studios that make those sorts of games, but these are games that are very niche. This one is in medieval Europe, this one is in space. But they're very niche, and the community really loves them, the community that plays them. And they expect a certain language and a certain set of features that really, they're not really obvious for a newcomer. So that's another example, something that's very resonant. But usually, if you want to do well, or a game that's actually very readable, would be something in the middle. Let's look at an analog example. Table soccer is something that's really, really resonant, right? Because football is a good metaphor for like the rules and like what's going on, the direction of the ball, basically what you have to do. But let's suppose that there's an apocalypse and everyone dies, and in 10,000 years aliens are going to look at our planet and they're going to look at the artifacts. Even without the metaphor, it's kind of understandable, right? Like you benefit from the resonance, but it's also very legible. The same thing could be said as well for Guitar Hero. The idea, the metaphor of being a musician really sells the mechanics and the logic very well. But if you have a hearing problem, you can still kind of play it. Right? It's a bit of both ways. So I hope I didn't bore you with all of these examples, but they were kind of necessary because the last time that I tried to give this talk, nobody kind of knew how to distinguish those two concepts. And without that, we can't really go into the math. Before going into the math, however, we have to look at how this plays out in the real world. So, what does that mean? What's that, like, that horrible terminology, heterogeneous, so horrible, right? Let's forget that, and let's focus again on information processing. As I said, information processing is about speed and accuracy, right? And let's look at another concrete example. In Dishonored, and many, many other games, this is not about Dishonored, you will maybe parse the setting, read where you are, like what's going on, the narrative. You will see, there's actually a bunch of rats, and like there's whales, and like you will be immersed in the mechanics, and suddenly something happens that kind of changes the way you see the game. So in this case, you might get power where you can possess anyone. And that's really nothing transformative, right? No, actually, because then you're like, actually, I think I can also possess animals. And suddenly, a ventilation shaft that looked like a set prop thing, like cosmetic thing, is actually a pathway because you can possess the rat, and now you can infiltrate the level in a different way. So what happened here? There's a clear delta or difference, there's a clear delta of time here on the readability. If we were to try to understand what's going on in this picture, maybe you could have an idea. But as we go along, you have a clear and clear idea of what's going on, and then, oh, it's a vista with 3 cows. That's not what happened with Dishonored. With Dishonored, something more like this happened. It's all blurry, then you move, then you move. You are reading stuff, but there's still stuff that you are misreading. You haven't understood completely the context. And then you keep moving and you keep moving, and some elements read faster than others. So basically, those 3 cows read with more time. That's the same with those 2 elements. There's a delta, there's a difference in time, and therefore, in Dishonored, at least in this scenario, there's a delta in readability. That's where the math starts coming in. So the actual math stuff, please bear with me a bit. If you really hate math, I promise this is not that deep. It's actually a bit shallow. When I've been talking with designers, no designers kind of agree with one another, but from talking with other people, I have the idea, or I took the idea that this legibility and resonance, actually the balance, the readability is actually a combination of both. So we could make the argument that readability is this equation. Readability is resonance times legibility. And you're like, that's not real math, right? You could just add those. No. If we were to add those, actually we would have a problem, because there's actually no reason why something plus 0 would be something other than 0. Whereas with a product, it starts making sense. Look at this example. You're playing a shooter. You've played tons of shooters. Actually, you're a fan of this franchise. It's the 10th game. You know everything about it. It's incredibly resonant. And then, bam, you die. And you're like, no, that doesn't make any sense. Like a grenade. Where's the grenade? Actually, the grenade was here. So the icon is barely legible. So resonance and legibility kind of, if one is 0, the result is going to be 0 as well. So let's put a pin on that. Let's move forward. Actually, let's not move forward. Let's give it a name, a stupid name. Let's pretend that this is an actual math talk, and that you are actually learning something, and that the ticket cost was actually worth it, and you go out of the talk and you're like, I learned the law of readability. You're not going to find the law of readability anywhere online. It's not a thing. We're just going to pretend, just to give it a name. We're going to pretend that it's actually a thing. You won't find it in a book, or it's just for us, right? Let's move on. We talked about the delta readability, and we talked about that as a difference in time, right? The example that I gave was something that reads really fast, like the rest of the game, and then another element that reads a bit slower. In practice, actually, there might be other layers. Actually, instead of 4 layers, there might be infinite layers when you're playing a game. And I gave the example of Dishonored, but honestly, you will, like most games, interesting games have that. Like someone told me, actually, you should use Zelda as an example. And I was about to put Zelda instead of Dishonored, but like I couldn't pick an example. Like the Breath of the Wild, the last one, you keep like a tree is actually something that you can fly in. It's like all the time you're learning new stuff, but stuff that was already in front of you. So we could say that the difference in readability, the heterogeneous, I can't pronounce that word, the delta readability, maybe we're going to keep things simple, is actually the thing that takes the most time to read, minus the thing that takes the least time to read. That's actually an interesting measure, right? And I gave an example for Dishonored, like this is a systemic example, but let's say, even narratively, this kind of makes sense. I don't know if you've ever played Firewatch as well, but in Firewatch, it's not really systemic, but like you don't really know what's going on. There's always new clues. When you kind of know what's going on, new things start appearing. You don't know, like, is someone watching me? Like, am I gonna meet someone? Like, what's going on? Is the FBI? Like, you keep getting new cliffhangers, so the readability of the situation never converges into a new thing, right? And again, we want to make fun games. So actually what I'm gonna try to do is somehow make this all related to fun. Fun is a dirty word because like it means different things in different contexts. Engagement, on the other hand, is a very objective word and it can be measured in time. So we could argue, and this is, again, this is not math, right? But we could argue that engagement is, among other things, because you might be playing Dishonored because you like systemic games and because you like stealth games, that if you ignore all of that, maybe you like rats, right? But if you ignore all of those other components, some aspect of engagement is the delta readability. That's another equation. Actually, this equation is wrong. And here's why. We used the example of the cows, but imagine that instead of going into more clarity, we were going like this. So the delta readability here is actually really, really high, but that doesn't mean it's very engaging, right? So it's not just that. It's the difference in readability and the thing that's the most readable needs to be really, really, really readable immediately, right? We have to have a balance for that. So first thing, having a balance between resonance and readability. Second thing, the delta readability needs to be very high, but the lowest readability needs to be very, very low. So that was the law of readability. Let's call it like something even more goofy and more academic. Fundamental law of readability. Now we kind of feel like we're learning stuff, right? Like we're all specialists in math now. I'm sorry for people who wanted to learn about screen shake and all of those very math-heavy stuff. Like, but I think this is approachable, right? And for the final math trick, this is actually a lie. This doesn't make a lot of sense. Here's why. So this works, right? Like if 1 is 0, the result must be 0 as well. But what about Thumper? Has anyone played Thumper? I've watched people who've never played games. I've actually given the controller to a kid, and you can barely understand what's going on in the screen. Like like first time that I saw screenshots, I didn't understand what was going on. But as you play it, it's immediately intuitive. People immediately understand what's going on. Even though it's not resonant, it doesn't look like anything else. So, another example, the Return of Obra Dinn. The Return of Obra Dinn is a weird game in a weird setting, doesn't look like anything else, doesn't have a tutorial. Most people understand what's going on, even though I kind of can't explain what's going on. You are a time traveler that is also an accountant in a ship where everyone kind of died, and you're like doing a detective thing where you're trying to, it's a bunch of things and it's bananas as a setting, but it's immediately readable, even though it's not resonant. So our law is kind of broken, because this doesn't make a lot of sense, right? It's not really resonance times legibility, it's resonance times legibility plus legibility. So what does that mean? Yes, you need to have a balance of resonance and legibility, but if there's a tie, legibility wins. And that's the actual law of readability. So let's go over what that means. You have to have a balance of both, but one wins. This, which I lied, is not the law of readability, is the simplified law of readability, means that you should always strive to have a balance because the interesting games have a bit of both. And the fundamental law of readability. Yes, engagement is about learning new stuff, always new stuff, and if in 10 hours of playthrough you still are learning new stuff, it's good, but you need to hook the player immediately. The least readable stuff needs to be immediately readable. And those were the 3 math tricks that I wanted to share with you. So if you like the talk, please follow me on Twitter. If you have any questions, I'm not sure if we're going to have a QA time. Anyhow, thanks for listening, and yeah, thank you.
Thank you very much.